All right, today for section 7.2, we have two new theorems that are going to help us do proofs in this section. The first one is, if two angles of one triangle are congruent to two angles of a second triangle, then the third angles are congruent. Well, it makes sense because we know the sum of the interior angles of a triangle add up to 180. And so if two angles are congruent to of one triangle are congruent to two angles of another triangle, the third angles would have to be congruent by that sum rule. So we call this theorem, we call it the no choice. There's no choice for that third angle. So in our reasons, we just write no choice. How it looks here, let's see. We're going to mark our given. Given A is congruent to angle D. Let's do this proof here. It's a short one. We can fit it in right here. Statements, reasons. So we're given angle A congruent to angle D. We marked our picture. What else we can mark on our picture are these vertical angles in the middle. So let's go ahead and say angle ABE is congruent to angle DBC, and that's because vertical angles are congruent. So we want to prove that angle E is congruent to angle C, and we can say that now. We can say angle E is congruent to angle C because we showed the other two pairs were congruent. The third pairs are congruent by no choice. We could say the no choice theorem. It probably looks a little better, just the no choice. But it's the no choice theorem. If two sets of angles are congruent, then the third angles have to be congruent as well. All right, the next theorem we have today is the AAS. That looks similar because in our toolbox, we have had many ways to prove triangles congruent. And so in our toolbox so far, we've had side, 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 angle, angle, and hypotenuse leg. That's all we've had so far. Now we're going to add one more tool, angle, angle, side. And as you can imagine, just like the picture shows here, the order does matter. Remember, for angle, side, angle, it's angle, included side, angle. It has to be in that row. Now you can see we have angle, angle, side. The side is not in between or included between those two angles. Well, let's take a look at a proof where we use our new theorem. Now, this one is difficult only because the picture's not drawn. Let's take a look. This is actually from the homework, number 12, which of course you won't be assigned it then, but we're going to do number 12 from the book. So it says, prove that the segments drawn from the midpoint of the base, so midpoint of the base of an isosceles triangle and perpendicular to the legs are congruent if they terminate at the legs. So let's start. We're going to start by drawing an isosceles triangle to the best of our ability. Here's our isosceles triangle. Our sides are going to be congruent. Let's mark this as A, B, C. Now, midpoint of the base. Here's my midpoint of the base. I'm going to call it M. And we're drawing segments to the perpendicular to the legs. So it's going to kind of look like this. All right, that's our picture. So let's make our proof here. So it's a little interesting in that we have to write our own given here. So let's see, what were we given? We were given that triangle ABC is isosceles. Okay, we were given this. We were given that we have the midpoint of the base. So we're going to say M is midpoint of BC. And we were given this perpendicular. So we have, we need to name some points here. We'll call them X and Y. So we'll say XM perpendicular to AB. And we're going to say MY perpendicular to AC. So that takes care of all of our givens. Now, what else can we say? Well, I already marked in pink that AB congruent to AC, so we need to say that. So isosceles triangle, legs congruent. So we know that. We have M as our midpoint, so let's say MB is congruent to MC, and let's mark those here. And we know that because midpoint divides segment into two congruent segments. All right, so now let's see. We haven't talked about the right angles yet. Let's maybe talk about that, because remember to use angle side, which I assume we're going to use since it's new. We have to say the angles are congruent. So let's start by saying angle MXB and angle MYC, are right angles. And we know that because perpendicular gives us right angles. Now we need to say angle MXB is congruent to angle MYC, and that's because all right angles are congruent. So again, to use a angle side, we need to say those angles are congruent. So now we have those right angles are congruent. We need one more angle, and that is going to be angles B and C here. Because remember, if we have our legs congruent, those base angles are congruent. So we can say angle B, move this up a little bit, congruent to angle C, and that is our, if the legs are congruent, then the base angles are congruent. So now we can say, remember, well, let's just write here. Remember, we want to prove XM is congruent to YM. We want to prove that these segments drawn from the midpoint perpendicular to the legs are congruent. So we are almost there. We can now say triangle MXB congruent to triangle MYC, and that is by AAS, and then finally we can say XM congruent to YM, and that is by CPCTC. So nothing that new. It's one more tool in our toolbox of ways to prove triangles congruent. We now have AAS, and then today we also learned the no choice theorem. That is, if you have two angles of one triangle congruent to two angles of another triangle, the third angles have to be congruent.